I hope everybody had an enjoyable trip in. Mine, as always, is like a last minute thing where I'm, got 5 things going on. I forget to plan my trip. So I called my assistant yesterday. I said, look, you got to get me to DC. And she said, well, why didn't you tell me earlier? I said, well, don't you know me by now? I'm not good at planning. And I said, don't worry, if you can't get me a hotel, you can't get me a flight, I'll take the train and I'll stay with my son at the Maryland Lacrosse house. It's fine, just get me there. So a few minutes later, she called me back. She says, good news. I said, what's that? She goes, first class is available. I said, really? That's odd. I'll take it. So I jump on the flight. I said, but what about, am I staying with my son, or did you find me a hotel? She goes, let me call you back. And she calls me back shortly after. She says, geez, you're not going to believe this, but the Ritz-Carlton has a room. I said, really? She goes, not only that, but they're going to upgrade you. I was like, wow, that's fantastic. This is great. So I get to the airport. There's no one in the airport. I go right through the security. I was not a person in line. I get on the flight. I get off the flight. I'm in Washington, D.C. I go out to get my car, which is always a nightmare because there are these guys that shoo all the cars away. So they're just looping around D.C., waiting to come back in. And sure enough, my car's parked out there. And I'm saying, wow, what happened to all the guys that shoo the drivers away? I get in the car, no traffic. I get to my hotel. I walk in, it's late. I just want to have something to eat. And so I go to the concierge. I say, no, it's late, and restaurants are closing, but you get me a good, I know this restaurant I've been wanting to go. You think you could get me a reservation? Just hold on one second, Mr. Walsh. He calls down. He says, for how many people? I said, I don't know, there's a few of us. Call it 4, 5, 6. He goes, no problem. 1 second, calls over. Yeah, what time would you like to be there? I said, how about now? He goes, fine. How many? I said, yeah, make it 6. He said, great. There I am. I said, I cannot believe I get this hotel reservation. I get this flight. I get this dinner reservation. Everything's going fine. This morning, I'm walking to the hotel and saying, man, this is really going well. When's the shoe going to drop? And I see the doorman. He says, Mr. Walsh, how you enjoying your trip? I said, you know what? It's amazing. Everything's going so well. He goes, yeah. He goes, everybody's been telling me that. He goes, I think it has something to do with the government shutdown. So anyways, the government shut down. I'm not worried about it being shut down. I'm worried about turning it back on. So we're here to talk a little bit about the PSTN sunset and sustainability. This is something near and dear to everybody's heart. But I thought maybe we would scroll back, just a refresher course on the history of the PSTN. In 1876, Bell patented the telephone. And then it took 15 years for the first generation switch to get to the market. It was called a step-by-step. It was invented by a guy named Almond Stroger, the Stroger switch. Now, the interesting story about this guy is that he was an undertaker in Kansas. And he developed the switch because people were tipping off his competitors, meaning the telephone operators were tipping off his competitors when local citizens died. So he goes, I'm going to have no part of that. I'm going to get the people out of the way, build a switch, and then I'll level the playing field. So that's really how the central office switch got developed. Then it took 29 years for Western Electric to come out with the panel switch. Another 18 years, which was like 1938 at that time, the crossbar came out. Some of you will remember that, if you're as old as me. Another 17 years went by before it was like 1955 for the first electronic switch. And then from 55 to 65, and then you look kind of between 65 and 82 is when all the commercial products that, kind of made the industry, the number 1 ESS, the number 2, the 3, the 4, the Stromberg-Carlson, the EWSD, the DMS 100, and the 5E, all came out sort of between 1965 and 1982. And then it was another 18 years before the soft switch, around 2000, came out. So today we are living with a set of switches that are anywhere from 10 to 36 years old. It's really amazing. And this industry is 125 years old. Now, one interesting fact that I didn't realize about, just telephony and networking is that still today, while a lot of people say, voice is dead and it's gone, more than half the people in the world have never made or received a phone call. That's really amazing. And we've already said it's not something that's important anymore. So look, we're looking at the PSTN and say, where to from here? And it's been around in our lives. It's been such an important utility. It's probably not a more important utility than the PSTN has been and served us over the last 125 years. So now what we're looking to do is, how do we bury this with some dignity? Because that's what it deserves. So with that, I want to cover a few things that I think are important to that whole prospect, which is, why do we need to change? Like, what's driving it? A lot of people have said, well, you know what, maybe we could just let this thing die in place. And you probably can, but the consequences of that are pretty severe. And the problem right now is not a technology one. It's just that this whole entire infrastructure is really expensive. It's a massive power expense. It's a massive water hog. It's a big producer of CO2. So it's something that you really can't wait. You've got to move. So when you look at the OSI model, something we've looked at for the last 20 years, and there's been enormous amounts of optimization in all the layers, right? I mean, if you can get another 1% of improvement in either productivity or efficiency, that's like a good thing in the OSI. So whether it's layer 1, 2, 3, 4, 5, 6, 7, there's all this optimization that's been going on. But there's a layer below called layer 0. That's the mechanical and electrical infrastructure this all sits on. And there's been zero optimization in that. None whatsoever. Almost, since Carrier invented the chiller plant 75 years ago, there hasn't been much improvement. So what you see over the last decade is that the mechanical and electrical part of the network is growing and becoming much more important. So we're going to talk a little bit about, I'm going to show you a little video on that. But here's some interesting things to think about. See these lights here? Only 10% of the energy, if you look at how much power goes into a power light, 10% generates the light. 90% of it generates heat. So we think of them as lights, but they're really heaters. And we have thousands of these heaters. That's how inefficient power is. So another point is that for every dollar that we spend today powering these networks, these PSTN networks, we spend at least another dollar cooling them. So it's very, very inefficient, and it's only getting worse. So if we look at what's happened over the last 30, 40 years in technology, you'll see this, there's been this massive optimization in computing, in storage, in networking, but on the other side, nothing on the power side. So take storage, for example. In 1960, a gig of storage was $1 million. 1995 it was $100. 2010 it's 10 cents. That's pretty dramatic improvement. If you look at RAM, in 1980, it was 6.3 million. In 2000, it was 1,100. In 2013, it was 5.5 bucks. Internet transit rates, 1998, $1,200 a megabit. 2000, 675. 2005, 75 bucks. 2010, 5. 2013, it's $1.05. So, but if you look at that same period of time, while there's just massive compression and optimization going on in network and storage and all the technical infrastructure, power costs in the last decade have gone up by 50%. The consumption, the amount of power that servers are consuming has doubled. This has led to a tripling of your power cost. So you really got to look at these networks as being tied. There's a big electrical plug that goes back to these massive power plants that are burning huge amounts of coal. That's what's really going on behind the scenes. When you open up the door, you might say, I see cabinets. Murat and I, what we see is coal. That's really what's happening to keep these things up. So as mentioned, I got a slide here that's pretty cool on cooling. before I get it going. The chiller plant, which is the thing that big, ugly infrastructure that's in all your data centers and it supports all of your central offices. The first one of those was developed by a guy named Willis Carrier. You still know the name because they're still in business. And he got started in 1921, and then his next competitor followed in 1939, a guy named Reuben Train. Train is still in the business. These are still the market leaders today, which is extraordinary. It's very unusual to see a company 75 years later, and the two that got started are still here, but there's been little to no progress. So here's a fun video that talks about cooling and data centers.
Aligned Energy works with companies to align and optimize their infrastructure and energy supply chains to drive the greatest business value. Why and how? To answer that in the next 3 minutes, we are going to do 3 things. Refresh ourselves on the history of man and how we got here. Discuss the current digital infrastructure problem and how we can solve it. And create a better planet. 3 minutes is not a lot of time, so let's get started. The history of man. It's always been about coming up with great ideas. Fire led to an engine, which led to the Industrial Revolution, which used an incredible amount of resources, leading to a great economic engine. These were all great. Then came another great idea, the computer. A machine that could handle massive processes and create even more business value. And then there was that law our friend Moore taught us. Every year, every day even, computers were getting cheaper and at the same time getting faster, creating more and more business value. Which brings us to today, where companies all over the world continue to use the business value created from computers to buy more, even faster computers that create even more business value. It's a never-ending source of business growth. Well, of course, we all know that's not entirely accurate, which brings us to part 2, the data center problem. Every year we are figuring out how to add more and more transistors onto microchips, but this causes a major problem: heat. So how do we get rid of it? Moving your data center to the North Pole is not an option for most companies. Luckily, in 1920, man invented a great way to deal with heat. Suck out the hot air and replace it with cool air. And to get the cool air, we invented the chiller. This system had to be designed to handle the hottest day of the year, which made it very inefficient, used lots of power, and massive amounts of water. So here's the problem. It's almost 100 years later, and data centers are still using this same system. Apparently, Moore's law doesn't apply to infrastructure. Computer chips are getting cheaper and are creating more heat than ever, so the cost to cool and power data centers is going up, way up. And cost is not the only issue. The increased heat is resulting in a new phenomenon: indoor rain. And of course, the biggest part of the problem may be what's going on outside of the data center. Electricity, water, filters, and space needed to house all of this infrastructure is sucking away business value, putting your corporation at risk, and adversely affecting the environment. This is why Aligned Energy is focusing on cutting down the cost and the drain of resources needed to run data centers by over 50%. Part 3, save the planet. Well, that's the easy part. We solve the data center problem. We create an environment where computers can continue to provide more and more business value, and we can drastically decrease our use of water, energy, and space. The good news is that Aligned Energy hasn't only made this a goal, we're achieving it now for some of the largest companies on the planet. Our Intertech division has reduced data center cooling costs by 90%, and data center water use by 80%, and cut delivery times by 5-fold. Our Energy Metrics division is the first supply chain management tool for infrastructure and energy that allows companies to drive greater business value by optimizing infrastructure. And our carbon engineering division works with companies to deliver continual improvement processes. Just imagine what we can do for you.
So what we're seeing is that you can't just look at the network anymore as a networking appliance or a series of appliances that are connected together. You actually have to look at what's driving that infrastructure. And typically what we used to think of is driving that infrastructure, all the servers, the storage, and everything else. So you thought about the fiber network in the ground and how do you provide the connectivity, how do you deal with the speeds and feeds to make this all work. But now what people realize is that this layer 0 is an enormous problem. And while we're seeing optimization in every other area, all we're seeing is the cost of energy going up. So this means that at some point that we're going to have to address how we manage our business and what we can do differently. So if you look at what the opportunity for PSTN sunset, there's millions of kilowatts of power savings that can be taken out if we sunset the PSTN. Removal of thousands of frames of equipment, elimination of millions of circuits. So you talk about massive reduction in energy, substantial reductions in risk, huge pickup in resources that could be deployed elsewhere, freeing up of a lot of real estate, and a dramatic reduction in water. So there's a lot of benefit that could be seen by shifting this over. So here's an example. Numbers globally, we estimate about 12 billion kilowatt hours consumed by the PSTN. And we think that that could be reduced by migrating that by about 70%. So power costs can come down by 70%. This is massive amounts of power. These are thousands of generators and elimination of the need for lots of new plants, power plants, if we could just sunset the PSTN. And what's also, I think, most interesting is what could this savings that comes with the reduction in power be deployed to do in a positive way? And there's we estimate about $1.3 billion of potential savings annually. So that's enough money to completely transform most of the networks that we're living with. So there's a huge opportunity now to move from the old legacy networks to a whole completely new infrastructure and get it financed out of the savings of the power, the water, and the operations. So let's take a quick snapshot of the PSTN today. If we look at financially, you see this declining voice, both lines and revenue. It's not offset by OpEx cost. Today, there's a minimum fixed cost to keep these networks running. ARPU is flat to down. The network, if you look at that, costs are increasing, obviously. The power costs are going up. It's support and the skills to support the old network, they're leaving. People are retiring. So there's a lot of increased risk right now with this network, not just increased costs. So what is the opportunity? Well, in voice, there's a lot of value still in some key segments. So if you look at enterprises, they highly value voice. As an example, the first thing I do when I get inside, I get right onto my voice line because the quality is better. Call centers are a big growth business and they are highly dependent on high quality voice. But the real opportunity going forward is having a multimedia infrastructure that can deal with what's coming around the corner. And what's coming around the corner, and you hear machine to machine or the Internet of Things, but that's where we have to move from the voice-only TDM world to this Internet of Things. We have an Internet today. It's evolved nicely over the last 15 years. It allows for everyone to connect to anyone at any time. But the next evolution of that, which we have to build our networks for, is when devices and things become smart and start talking to each other. So I'm involved in a company that's going to be coming out in about 3 or 4 months and talking about what they're doing. They're perfecting a lot of their technology, but it's absolutely amazing what can be done by making any device smart. So if you have a smartphone with an application, you could touch anything. You could touch the speaker, you could touch the jacket, and you could do a search by touching your jacket. You could take out a dollar bill. You could just figure out if it's counterfeit. So what's going to happen now is your device is going to be the way that you search. Your device is going to be the way that you explore things, explore the world around us. You don't need to try to figure out what this is, because you can tap it and it'll tell you what it is. That's where the world is going, but how do we finance an infrastructure, a complete transformation? And what we're going to do is we're going to talk through this presentation, and Murat is going to describe how we can finance it. What Genband's been doing over the last 10 years is building technical infrastructure that'll allow the telcos, all of you, to make this migration. This migration from TDM to multimedia. So if you see all the activity, we've done a lot of acquisitions, we've made some massive investments, in our business around these areas. It's all around trying to move everybody to this new world that's coming. But the obstacle that we hear is, how do you finance it? So that's the next step in what we're going to talk about. So with that, I'm going to turn it over to Murat, and he's going to tell you how we can finance the transition.
Thank you, David. I feel like I've been following David around, and to put the relationship in context, it's like you go to the GM dealership and you want to buy a car, and you pick out everything you want, all the features, and then when it comes time to pay for it, the salesman sends you down to my office, and then to figure out how to finance it. But it is a pleasure to be up here, our first time together up on stage. I am a little bit of an energy efficiency finance geek, and since I entered this industry about 4 years ago, I've been in clean tech finance for now 9 years. But I certainly welcome the opportunity to talk about it, because at cocktail parties, it's really not going very well. The eyes tend to glaze over when people ask me what I do. And the way I came into this work with Genband is I'm a bit of a wildcatter. So in the old days of oil in Texas and so forth, people were looking for wells, sources of energy. In this modern day, what I'm doing is looking at how do we find efficiency at the industrial scale, and in order to achieve the savings within the system, it's a large capital expenditure. And so what we do is it's the magic of converting a CapEx to an OpEx. And another way to think about it is we're the bridge between the network and operations people and the finance department. And so hence the following David around. And typically, when you look at solar panels, wind turbines, you think of these as energy sources. And when I came upon the Genband technology, the TDM networking technology, some of this equipment is 90% more energy efficient, or even more, I think up to 94% more efficient than the equipment it replaces. And in my world, that's a massive opportunity. And so I'm going to just tell you a little bit of how this is done, how it's accomplished, and then give you a case study. And so here we go. What we basically do is we set up a special purpose vehicle, an SPV, and we follow the Genband team go in with their engineering team and scope out a project. And then our engineering team comes in and helps optimize that based on efficiency parameters. And that would have to do with in which markets have the highest cost of power, and which systems are the most inefficient. And then so there's a reconfiguration of the scope of work based on the financing mechanism. Then the telco actually, we do an agreement with the telco into the SPV to assign the future energy savings. And this isn't a new concept. The ESCOs, the energy services companies like Johnson Controls, Honeywell, even Trane and Carrier have similar programs, Lockheed Martin, for performance contracting, for buildings efficiency. But they don't do it for the network infrastructure. And I worked for a bunch of years with the ESCOs, with Lockheed Martin, helping them design a commercial application based on their federal and military service. So what we do is the telco assigns the future energy savings to the SPV, and depending on the credit rating of the telco, that can range from 7 to 10 years, 10 if it's a lower rating, and 7 obviously for a higher rating. And of course, this depends on the scope of work. And then the SPV contracts with Genband to do the construction and commissioning phase, and that can last up to 3 years, can be done, the range is basically 1 to 3 years. And it's incremental, so as switches come online and start generating savings, those savings are realized and go into the SPV. And what we do is then we go out to the capital markets and get the investors behind that cash flow. And that's the basic foundation of the agreement. What happens next is there's also a lot of rebate and incentive capture opportunity that the telcos presently aren't availing themselves of, even when they do standard replacements, because it's somewhat complicated. But we're also in dialogue with states and public utility commissions and so forth to actually generate incentives around projects that have significant attributes. Because the government, in certain governments, they're very much trying to decrease demand and bring in clean technologies. This is a no-brainer when you look at the scale of the opportunity. So that's the basic mechanism. And another attractive feature of it is that presently the telcos are ostensibly providing maintenance on their current network. The maintenance agreement, and in this case Genband Care, gets rolled into the service agreement. So the telcos don't actually pay for that service contract, the SPV does, and those are cash flowed out of the savings. And the goal with these are to have it cost no money down for the telco to do this. Very much like the financing schemes you see at Best Buy and such, certain terms. So anyway, the case study that I want to take you through has 86 central offices with 104 switches that will be condensed and collapsed into one switch and 39 gateways. To do that work, it's going to take about 3 years, and that will generate about $8 million a year in energy savings, so over the term of the contract, it's a 10-year contract that includes the 3-year construction phase. Typically, in the ESCO market, you'd have the construction phase, and then you'd have the commercialization phase, the production of the savings. And so the program reaches cruising altitude at, for about 7 years, but there is that 3-year construction phase. And this program will actually cut the power usage for the entire network in half after 3 years. So it's quite significant. And there are an extraordinary amount of other OpEx reduction savings from the battery backup systems that get cut in half because of the much decreased demand, the freed up real estate, the taxes associated with that real estate, the taxes associated with the actual equipment, because this equipment is all owned in the SPV, and so the SPV pays the taxes on it, the insurance on it, all of that. It actually technically owns the switch in this case. That's not in all the cases. It just depends on whether it's an off-balance sheet or on-balance sheet solution. And so that's and what the telco in this case gets is a brand new network that's de-risked, because right now that network is facing some serious challenges. So that's the basis of our work, and I'm going to turn it over back to David for a short video.
Okay, thank you. So what we've found is we know that we have to make the change, and we know one of the obstacles is financing that change, and we've been working hard at figuring out how do we make that easy? How do you make it a no-brainer? And it looks like we've found something that's very interesting. We're having these conversations with many of you that are here. And we think that this is a unique way. This approach has been applied in many other markets, so it's not new. It's just new to us. And it's very unique. It's a moment in time because of the legacy infrastructure that we have, and the cost of power going up creates this new opportunity. So I think the way you can look at it is sunsetting the PSTN. What we're calling this is a sunrise of the next generation networks, because what we think we can do is we've cracked the code on how to off-balance sheet finance this transition. And we feel Genband, we've invested for the last 10 years to ensure that we have the depth and breadth of product and capability and resources, not just the technical capability to do it, but the resource to actually make that happen, because this is an enormous amount of work that has to be done. So we're really excited, and what we want to do is get the industry to a place where they can exploit what's coming. And that's where we think the Internet of Things, where everything is smart, everything is communicating, it's real time, and the infrastructure we have today can't do that. Or it can do it, but in a very limited form. And that's where there's real opportunity for business expansion. So the faster we can get you off the old and onto the new, the better off we're all going to be, and we're going to be to exploit the opportunities ahead of us. So I've got a quick video to end. It's just 1 minute. We call it the Internet in a minute. So we'll leave with that, but I think you'll enjoy it. Thank you.
This is how an angel cries.